In topic two, we're going to discuss rationalizing denominators containing two terms. So you're going to have the sum or difference of two terms, and at least one of those terms is going to be something that's got a radical in it. Okay. Now, to rationalize a denominator containing two terms, we multiply the numerator and denominator by the conjugate of the denominator. We've talked about conjugates already. So remember, when you're dealing with anything radical, like when we're dealing with like the sum or difference of radical expressions, we can have a situation where we have conjugates. So if we had something like A plus B, the conjugate of that would be A minus B. So we have the same terms, but in one case we're adding those terms, in the second case we're subtracting those terms. So that would be conjugate pairs. And the cool thing about multiplying conjugates is things simplify down beautifully. Okay, so this is going to be how we rationalize a radical expression, okay, where the denominator contains a sum or difference involving radicals. Okay, so remember the conjugates. Okay, and because we're multiplying the numerator and denominator, we're basically multiplying by a form of one. We talked about that in the previous video. You're basically looking for what some people will call a well-chosen one. So you're looking for some form of one, because we know if we multiply by one, we don't change the value. So our goal is to find an equivalent expression. We multiply by that well-chosen one, and it just forces things to happen for us without changing the actual value of the expression. So that's what's going to be happening here. So in example 2, it says rationalize the denominator. And if you look at part A, we can see right off the bat that the denominator contains two terms. So what we're going to do is multiply the numerator and the denominator by the conjugate of the square root of 6 minus the square root of 2. Now remember, a conjugate is going to be the same terms, but instead of adding, you would subtract, or vice versa. So in this case, we want the square root of 6 plus the square root of 2. Now, for the numerator, you're either going to have to do like that radical version of the FOIL method, or you'll have to distribute. The denominator, you can do the conjugate multiplication. So when you multiply conjugates, remember, let's just go ahead and look at A plus B times A minus B. So if I have A plus B times A minus B, what happens if I do the FOIL method? I get A times A, which is A squared, A times negative B, which is minus AB, B times A, which is plus AB, and then B times negative B, which is minus B squared. Those middle terms always cancel out to become a zero. So essentially what you're left with is the product of the first terms of each expression minus the product of the second terms of each expression. So we can take that shortcut with the denominator, but you cannot take the shortcut with the numerator. Okay? So let's see. For us, we need to distribute for the numerator. So I'm going to take the square root of 2 and multiply it by the square root of 6, and then the square root of 2 again. So the square root of 2 times the square root of 6, that's going to be my first term in the numerator. And then my second term in the numerator is going to be the square root of 2 times the square root of 2. So I get plus the square root of 2 squared. We'll simplify that momentarily. Now, for the denominator, you are welcome to do the full FOIL method if you would like. I'm going to do the FOIL, or like the conjugate shortcut, where we just multiply the first two terms and then multiply the last two terms and then simplify. Okay, so my first terms are the square root of 6 times the square root of 6. So I get the square root of 6 squared. And then I get negative square root 2 times positive square root 2. So a positive and a negative become a minus, so subtraction. And then I get the square root of 2 squared. Okay, now remember, if you have the square root of something and then you square it, you just get the radicand. The square root and the exponent of 2, they just unravel each other. They undo each other. So you're just going to be left with the radicand. So looking at the numerator, we have the square root of 2 times the square root of 6. I'm going to go ahead and push that under one radical. We'll simplify it in just a minute. But the square root of 2 squared is just 2. And then in the denominator, the square root of 6 squared is just 6. The square root of 2 squared is just 2. So my denominator is really just 6 minus 2. So let's look at the numerator a little bit more. So in the numerator, I have the square root of 6 times the square, or well, I had the square root of 2 times the square root of 6, which is the square root of 2 times 6. I can rewrite 6 as 2 times 3. So my numerator, what I have now is 2 times 2 times 3 plus 2 all over 4. And remember, if you're dealing with a square root, you're looking for one of two identical factors of whatever that number is. So when we're dealing with a square root, we're always looking for pairs of identical factors. If you find a pair of identical factors, that factor comes outside the radical. And I just so happen to have a pair of 2's. So that tells me a 2 comes outside the radical, a 3 stays under the radical, and then I have 2 square root 3 plus 2 all over 4. Now we can simplify this final expression here. So you can do it two ways. I'm going to show you the way that I think students struggle with the least, I guess. Do I want to do it that way? I'll show you both ways. Let's do that. So method 1, you have to be kind of savvy with the first method. I noticed that each of the 3 terms of this expression, the numerator contains 2 terms, term 1 being the square root of 2 times the square root of 3, term 2 just being 2, term 3 being just 4. They all have a common factor of 2. So I could go ahead and just divide a 2 out of all of these. So 2 divided by 2 is 1, 2 divided by 2 is 1, 4 divided by 2 is 2. So that makes this simplify to 1 times the square root of 3 plus 1 over 2. You could leave it like that if you wanted. Method 2, you could go ahead and break this apart into the sum of 2 separate terms. So we could do 2 square root 3 over 4 plus 2 over 4. Well, 2 and 4 have a common factor of 2, so I divide 2 by 2, 4 by 2, 2 by 2, 4 by 2, and you get the square root of 3 over 2 plus 1/2. These are exactly the same, okay? Like they're the same thing. So this right here is exactly the same as this right here. And what I would say is in your homework, if you type in one answer and it says you have the right answer in the wrong format, try the other version. I'll accept either. Okay. Now for part B, we have the same situation. We have a denominator that contains the sum or difference of something involving a radical. So we want to start by multiplying the numerator and denominator by the conjugate of the denominator. So the denominator is currently the square root of 5 minus the square root of 2. The conjugate of that would be the square root of 5 plus the square root of 2. And this right here that I've just written out, that's our well-chosen one, okay? Now, for the numerator, I'm going to have to flat out do the FOIL method, okay? For the denominator, we can take the shortcut. So let's go ahead and start the FOIL method for the numerator. So I'm going to start with the square root of 5 in the first expression and distribute that. So the square root of 5 times the square root of 5 is the square root of 5 squared. The square root of 5 times the square root of 2 is just the square root of 5 times 2. And we can merge it all under one radical since they both have a square root. Now I'm done with the square root of 5. I'm going to pick up this 4 right here, and then I'm going to distribute that. So 4 times the square root of 5 is just 4 square root 5. And then 4 times the square root of 2 is 4 square root 2. Now the denominator, I can take the conjugate shortcut. So we can multiply the first 2 terms and then multiply the second 2 terms. So in the denominator, I have the square root of 5 times the square root of 5, which is the square root of 5 squared. And then I have negative square root 2 times positive square root 2. That's minus the square root of 2 squared. So let's see if anything will simplify here. Okay, in the numerator, the square root of 5 squared is just 5. The square root of 5 times 2 is just the square root of 10. The square root of 4 times, or let's see, 4 times the square root of 5 is just 4 times the square root of 5. And then I get 4 square root 2. So unfortunately, nothing in the numerator simplifies, which is icky, but that'll sometimes happen. The denominator, let's see, the square root of 5 squared is 5. The square root of 2 squared is 2. So we end up with this horrible looking 5 plus the square root of 10 plus 4 square root 5 plus 4 square root 2 over 3. And that would be your final answer. Okay. So that is rationalizing denominators. You will most definitely see both situations here. Anytime you're dividing rational expressions where the denominator contains a sum or difference, you need to remember multiply by the conjugate of the denominator. You're going to definitely see a lot of this where you have the single term. Like right off the bat, the thing that comes to me the quickest is in trigonometry. You are for sure going to have to know how to rationalize denominators. The good news is it's typically very easy. Like you're going to have to rationalize where the denominator is like the square root of 2 or the square root of 3. So the rationalizing isn't bad, but just make sure you understand the process and what is expected of you.